Good evening again. I am talking about errors. So errors, it is something like that when we process something or something is you take from somewhere, and then when you analyze, so these errors are also come into picture. And then it is very important in case of GIS. When you were also told digitization, so there are some errors, digitizing errors, undershoot, overshoot, etc. And then when it comes to accuracy, it is something degree on which information that something whether whatever you generated is how much it is near to the true value or the accepted value. So that is the accuracy. Suppose when you digitize, you are whether you are able to follow the line exactly on the line or you are deviating from that. Or suppose if you get a coordinates from a GPS and the GPS coordinates and then what is the actual value of that place on the ground. So that shows the accuracy. Now precision refers to the level of measurement and exactness of description in a GIS database. Give an example, suppose if you take again the GPS and then go to the ground and take the measurements and then you try to measure in different coordinate systems in different units. Sometimes we measure in degree, minutes and seconds, and the same thing if we measure the distance in terms of the meters. So the precision in which you measure that the distance. Suppose I am measuring the distance on the ground. The instrument, what is the precision at which it is giving? So that means it gives in meters or decimeters. It changes from 1 meter to 2 meters or 1.1, 1.2. That means 0.1 meter is that is precision. And it is another example is if you take any measuring device or a weighing device, so you try to put weights and try to measure. So it is we measure in terms of grams, kilograms, etc. And then if you go to that balance, precision balance, where you measure gold and other things, so there even milligrams also matters. So that is comes under precision. So example of accuracy and precision. So if you talk about, if you see in that map, so there is a true line is the red color on the map, and then digitized line is in the black color. So the difference between that is shows the accuracy. If it says that if you do follow all along that line, so you say that means whatever is digitized is also exactly true as what is on the ground or what is on the map. The closeness of observations, computations or estimation to the true values, how much it is close to the true values. Precision is the smallest unit of measurement. As I give an example of balance, weighing balance, etc. So that is called precision. So you try to think yourself what will be the other examples. So probably you just think on that. Examples for error, examples for accuracy, example for the precision. So see, I have given some example. Maybe you should use some more your own mind and your own experience, and try to know what could be the examples for all three of them, and then maybe you can send back when we have interaction. So probably around 5:15, 5:20 at that time. So when you talk about errors, so there are three type of errors. So the errors which comes along with that, whatever the maps you use, whatever the data you use, so those are called obvious sources of errors. So in case of GIS, suppose if you take a satellite data, take a map, go to the ground and get it. So all those errors are coming in that. So errors resulting from natural variations. So you see, on the ground it is something, but when you digitize on the map, it is something else. So suppose there is a river embankment is there. So in the GIS map we show a simple line, but on the ground probably it is a bigger width. So maybe having 100 meters, 200 meters. If you go to big rivers, the river bank is very wide. So whether those things are all coming as errors resulting, what is there on the ground, how you bring it to the your system. So the variations are called in that errors, and then errors arises through the processing. Like when you digitize, you will get errors. So these are the three type of errors what you get in GIS. Out of these three, one is first is obvious sources of errors. So a majority of the data what you get from GIS for generating GIS themes is coming from the maps, like topographical maps, 1:50,000, 1:250,000. So there the accuracy will be depending upon the age of the data. Sometimes you make maps, they are made almost 20 years or 30 years back, and then now you are using them. So they might have been torn off, or they might be shrunken over the time. So all this also cause errors. And then another is a map scale. See, if you take 1:50,000 and then you put a dot on the map, if it is 0.25 mm, so then the size of the dot is 12.5 meters. And then if you take 250,000, then it becomes it's something like it's very big. Suppose it is 1 millimeter is equal to 250 meters, and then out of that 1/4 is 62.5 meters. So any minor change in that when you digitize also, so the same error also will come to your final maps. And then when you take points or lines on the map or getting from the ground, so the density of observations also makes a role. Suppose I am making a digital elevation map, and then I am collecting the points from the ground, so that the distribution of those points, how they are distributed, densely distributed or sparsely distributed. So your accuracy of final DM also depends upon the density of observations. And then there is a format. Simple example is, okay, you talk about conversion from one format to another format, or you say from one projection to another projection. So then also your accuracy also changes. And accessibility, sometimes what happens is because of the security reasons, we may not get the data what you require. So those areas you will not be able to incorporate the information, proper information. So for that, probably you have to go to the ground and get it. So at the same time, then it will also cost, or you are not allowed to go to the ground. So all these things plays a role. Cost also is very important. So the more and more cost you incorporate, then your accuracy can improve. But at the same time, the cost of the generation of the information increases very high. And second sources of errors are natural variation. In that, as I mentioned, example is the coastal line. If you take, I also given in the geographical phenomena. So there we are giving a demarcation of the coastal line. But what you are talking is the middle line of the coastal line. But it is when is high tide and then it is a low tide. So then the line also shifts. So because of that also your accuracy also changes. And then you talk about the positional accuracy. How accurate is the positional information when you have when you put a point, but on the ground it is maybe the bigger area. Where you put the center of the point, or you put the one side of the bigger area when you are converting into your GIS. Talking about maybe urban area, when you talk, whether you are taking centroid of that or you are putting at the edge of that. So the positional accuracy of that point also varies. And then accuracy of the content. If you talk about the content, we talk in terms of the qualitative and then quantitative. So qualitative means, suppose I take a groundwater prospect maps and I say you get a good groundwater in some area. You get the prospect of getting good groundwater is maybe medium and another is a low. So here what we are telling, we are not telling exactly how much water you are getting. When you are extracting water, is it liter per minute is very high in some place, this much is the 100 or 1000 LPM here, and then here 500, and here is 100 or less than that. So what we are not able to tell that, but we are telling that it is very good or high, very high, and then medium, low, and very low. So these are all qualitative information. So many times that also helps. That is enough for sometimes, but it is not always enough in many cases. So natural variations and bias. So if you see something, the natural variations you are getting on the ground, but you are able to put in the GIS differently. So those are all comes under processing these things. Natural variation. Another is the processing. Errors occurring due to processing is like numerical errors, and you take a decimal points, and then when you talk about when you overlay maps, and then there is a lot of when you talked about GIS, we told about many types of spatial analysis. If the logic works, so you are able to combine or able to subtract, but the meaningful information what you get, it all depends upon. So maybe you will get a colorful map, but is it that meaningful? What is required? Another is the errors also comes due to classification and then generalization problems. When you classify some of the pixels, when you take satellite data, they may go into two different classes. So then you are not able to decide exactly the pixel where it should be. And then generalization means you are more combining together, and then maybe taking class 3 information to class 2, etc. So because of that also you will get errors. So that we are talking about errors, and now other thing is the data. Data is something whatever you go there outside and collect. It is something, a collection of the data from the ground or from the maps, and then once you take from the satellite also gives in terms of digital number, that is also data. So and then you bring that into information. So another is the quality. Is the totality in the characteristics of a product that based on the ability to satisfy a stated implied needs. So this is the definition of the quality. Quality means you specify some guidelines. Suppose nowadays we say we talk about, there are so many GIS related guidelines we set in. So that way we will specifying the quality for the data. So when you talk about a GIS data quality, it is there are cartographic related, that is spatial information, and another is informal informational quality, that is whether it is following topological relationship, and another thing is whether the data is the what you are looking for is the same or it is something. A simple example is if you take some data. Talking about cadastral information, telling about information on the ground, particularly the land ownership of the persons. Suppose you use some 10 years back data and then try to correlate on the present conditions. So maybe the owners might have been changed and your data is not correct data. So that means the currency or timeliness of the data is also very important. And then completeness. Suppose you take map and then you digitize into your themes, and then you are able to digitize only some part of the data instead of the complete part. If you digitize only 80% of the information and 20% is still left, so that is 80% will be complete. And then correctness of the information, whether when you digitize you are given properly the themes correctly instead of giving one polygon to the another category, or you have given nodes for connecting the roads, and then there is a roads are there, and then a railway line is there. Whether you connected roads with a railway line, it is a blunder on that. So this checks has to be made. All these things comes under a data quality parameters. So if you talk about the data quality components, same thing like earlier slide what is shown is, you have a locational accuracy, and then attribute accuracy, temporal accuracy. Lineage means how the historical history of the data, telling about when it is generated and then whether it is for the present day or it is 25 years back. And then completeness, what I mentioned, and logical consistency, whether your topology is properly maintained or not. All these things you have to check, and then if something is not there, you have to go back and then create again correct the errors and then come back. In these errors, what we measure is a RMSE epsilon band. It is like the true line is there. From the true line, how this whatever is digitized is within the specified distance or not. If it is not, probably you have to redo it again. And then metadata is telling about the data about the data. So talking about the data and its data quality and all those things comes under a metadata. Metadata is also very important. Somebody is doing 10,000 map and then he wanted to create a very high accurate map. But if he use some information coming from 1:250,000 and then very small scale map, and then the information what you get is very primitive information when you're talking about 10,000. This is 250,000 is only level 1 classification. Suppose some build-up area is or agriculture or forest, but you don't have different classes. But in case of 10,000, we create a very high level of information. In the forest also, species also we try type of forest and then go to the species and then go to the density and then go to the slope category. So there are so much of information. So the higher the level of data, like larger the scale, then we have a higher the information. So this is talking about data quality. So that means you have to set in your data quality parameters and then check back how when I generate that, either it is generated properly or not. So that is talking about the standards. Another talking about the quality. Then the second component is the standards. The standards basically standards gives the specifications. These specifications when you use it and then you set your quality parameters. In this, if you talk about standards, every country have their own standards. Suppose in case of India, Bureau of Indian Standards, BIS, and then for every country they have their own standards. You might have heard about International Standard Organization. We talk about ISO. So it is also organization gives the standards for various things. Talking about a product and then talking about a processes and then output generation. So there are many guidelines are there. Suppose if you take about ISO 9000, it is something like talking about a product, talking about the process involved in that. If you talk about ISO 14000, it is environmental parameters, environmental related standards. Another is WSSN. It is a World Standard Service Network, and then is talking about mainly the web standards. And then there is also called International Telecommunication Union as part of United Nations. So they also come up with the some guidelines for the telecommunications. This thing. So our focus is not on this. So these are all the standards you might have heard or you might have noticed, or somewhere it is. If you go to a shop or if you go to a product, they say this is ISO 9000. So and then if you come to the GIS, so there are also standards for the GIS. So that is called one is ISO TC, International Standard Organization for Geographic Information. That is ISO Technical Commission 211. It talks about geographical information and geometrics. So this is the International Standard Organization giving the guidelines. In that guidelines also you will give that talking about a total framework and then talking about what should be the datum we use, what should be the projection parameters we should use, and then what are the content standards like roads, canals, all those things. And then then there are other organizations are also there. You talk about USA, they have their own standards. So that is called FCDC, Federal Geographic Data Committee, and then they developed the standards. So they call it as NSDI, National Spatial Data Infrastructure. So these spatial data infrastructures talk about the availability of the data from the at a country level, regional level, and then world level. In 1994 itself, when Bill Clinton was the president, so that time itself they came with a guidelines for the geographic data. So I think even before ISO, USA is the first start using the common standards and then developing the data basis on that and then making available for many users. So the standards is very important. If you don't have standards, suppose I generate some map for a particular area and then you generate some map for a particular area. So I try to bring both things. Means if both are doing for the same area, I bring it to the same, bring it to overlay one over the other. So they may not match, or that you cannot also combine together because of the different standard what is followed by two of them. So that's why it is very important having a standards. Another very important thing is one more is a OGC, Open Geospatial Consortium. So they basically give the standards, and then they also qualify any product. Suppose you talk about the GIS software is there, whether it is as per the OGC specified OGC standards. Something like giving a quality stamp on the product. Suppose it's basically what happens is when you talk about a product, software product like RGS, Erdas, and then you talk about PCA, Geomatica, or AutoCAD, MapInfo. So all this software suppose comes out and generate products and give it to you. But all these are compatible. Their formats are different, but whether we can exchange from one to other. So these parameters, if they're taken into consideration, and then they should, they comes under this OGC specified, that means the product is as per the standards, world standards. OGC also started developing a standards for this, for the geographic information data. So for the GIS data, so they are giving a product which is as per the standard requirement, specifying the give things, and then giving the product is again it is left to the product who develops that product, and then who markets, and who that goes to the industry. But OGC they give the standards, so that standard, and then people use it and develop their own softwares and products. Another is they also coming the standards related to the GIS. So suppose I wanted to generate a data, so they also give some guidelines. So this content standards, and then metadata standards, all these things are given, and then that thing anybody can use. So we can go to their website and then take the standards already developed, and then the thing is all these international organizations, so they are the bodies which gives the standards, but at the same time they also earn money through giving the membership. So anybody wanted to be a ISO specified, that means you should follow certain procedures, and then after following that they give the certificate. Okay, they are followed as per the quality guidelines, and then they are ISO certified. So similarly, they also give for the GIS data layer. So if you become a member, you are able to access and then get the information from that. You can go to their website, and then normal things may be available, but if they are doing new developments and then you also wanted to contribute to the standards, so then you should become a member. So what I am telling is, becoming a member, you have to pay some money. So based on that, whatever we pay, so international level, so basically they use this money for further enhancement and improvement in the standards. And then if you wanted to have a voting right on the standards, or to change the standards, so then you have to become a premium member as part of the main body. Otherwise, any universities wanted to become a member, they also can become members. We also, IRS also is a member of that, but we are done under the university category, which is very cheap. It is something like $150 per year. But if you talk about a premium member, so then you have to pay lakhs of rupees. It can go even 50 lakhs per 1 year. So that is, the cost is very high. And then before OGC and then this thing, there is also called GSDI. global spatial data infrastructure. So this is the national spatial data infrastructure used for particular country. So GSDI is also provide the standards for at the world level. So if you talk about climatic changes and climate change and weather information, you use a global data. So because everything is connected one to other. So for that you require some base information. So these bodies plays an important role giving the standard so that everybody input information into that. So they also take national bodies. So they also associate national mapping organization. So whatever the map is generated there, so it goes to the GSDA and then they collect from all the countries, and then whole map is ready with the information whatever is coming from the different countries or regions. Good evening all of you. Again some problem came in between. So it is something like the standards are very important and then they plays a very important role. When you wanted to exchange the information, combine the information, so and then suppose I am using some information related to the Hadoop, so somebody else also uses, suppose I generate some basic information, so why should the other person also generate? It's again huge cost on that. So similarly, the national level organizations, if they generate information, so that should be made available and then to be used for further developmental activities. So that talks about the standards. One is what we talked about errors, and then we talked about quality, and then the standards, and then the policy. I said earlier also, the policy plays an important role. Suppose if you take Indian conditions, aerial photography, it is there since many years. Like aerial photography is developed for military purpose for World War I and II. After that, many people started using for many applications, natural resources inventory, and then developmental activities and infrastructure environmental activities, because it gives a very high quality, high resolution aerial photographs. And then in America and other places, they started using extensively, even in Europe also. So they started generating maps to maybe very high resolution, talk about 10,000, 4,000 maps, etc. But you might not have seen that generation of the products of very high resolution, very large scale, you might not have seen in India. That was a problem because these aerial photographs were restricted to only for some certain applications. So that played an important role in not able to use aerial photography. The technology is there, and then capable to give a lot of information and can be used for many developmental activities, but we are not able to use because of the remote sensing policies. So these good policies, it will help for the peaceful uses of this outer space, and then it also strengthen the capabilities of the countries in space applications. So suppose I wanted to use space application for groundwater, use it for flood this thing modeling, or people affected due to the floods. So this is basically possible with the space technology. Suppose there is a lot of rainfall is there, but these things you wanted to do the floods. So, but at the same time, you will not be able to see through the clouds unless we have when you talk about remote sensing, and then it also helps in the international cooperation in space, and also it will help to resolve the regional and global problems. And then why do you need this Earth observation is understanding the worldwide phenomena, infrastructure development, sustainable development. So whatnot you can use for many applications. So to protect the planet Earth, to secure from external threats, and then to prevent from man-made and natural disasters. So it is basically it is not always help to prevent, but at the same time you can mitigate to certain extent. So we are talking about Earth observations, and then there are so many international bodies like United Nations Office of Outer Space Affairs, and then Committee on Peaceful Uses of Outer Space, World Meteorological Organization, World International Telecommunication Union. So these are all international bodies, plays an important role at the international level for various uses of space applications. When you talk about UN principles, so it is all relevant for all of us. What I am talking is United Nations principles on remote sensing on this. So they developed this very long back. There are 16 principles are there. It is something like that. What I mean to say is when you have developed some technology or space technology, and then everybody realized that a lot of advantages, lot of use because of the space technology. So these international bodies specified that whoever is having this, they should be able to they're able to make it available, these things, for everybody. So that is the basic principle of that. And then in this, if you talk about a space technology, and then in this everybody are not expertise or not having the technology or knowledge or expertise. So that means whoever is having this, so you should be able to spare to others. So that's why here we use two terms: sensing state and then censored state. Sensing state means, oh, I have a satellite, I can sense wherever my satellite goes. Suppose India. So India can become a sensing state. And then censored state means wherever I collect the information, that is called a census state, means a country. What you mean is, so all these type of things, whatever we do, so it should be made available for others. So this is what all the 16 principles says. So first principle is specifying the remote sensing activities. So and another is remote sensing activities for the benefit of all countries in accordance with international law. You cannot say that this is our satellite, I do whatever I want. So but you should follow that. What is according to international law? Remote sensing activity in accordance with Article 1 of the treaty, what was signed by many countries of India. Sensing states shall promote international. That means I have a capability, so you should be able to help promoting the technology for use. This is important point. If you see that states are encouraged to assist in establishment and collection of data through. Suppose I have the satellite, I receive the data. Suppose somebody else is there, neighboring country, so they are able to, they are not having a capability to receive that and not able to download and process. So they are in they are not able to use this thing. So internationally, UN says that you should be able to help them so that they should be able to receive the data, collect the data, process it, and use it. Participation of remote sensing, participating in remote sensing shall provide technical assistance to interest. That means the expertise you have, you should be able to spare. Shall promote international cooperation. Activities carrying out shall inform a registration of orbit as per the convention of the UN. So that suppose you are going to launch a satellite, so you should be able to inform that United Nations and then take the permission. Suppose even nowadays you say that I launch a satellite for the telecommunications, or I launch a satellite for TV broadcasting. So or you use what I say. So the satellite is used for many applications. You talk about what is that satellite data. One is, another is used for communication, used for broadcasting, used for meteorology. So for everywhere you require some transponders. So and then the bandwidth in which they are there, like a C band or KU band. So all these things, when you decide, so it also has to be informed to the UN and take their own consent. And then suppose you are going to launch a satellite, like geostationary satellite. After launch, it is coming in front of your country. So there also you have to take the slot. You have to take the slot. You have to buy the slot. All these things should be done as per the United Nations guidelines. So another is registration of the object is something like you're going to launch a satellite and that becomes an object. So that registration of objects and the slotting of those things has to be informed, taken consent from the United Nations. And then you see remote sensing shall promote and protect the Earth's natural environment, shall promote the protection of mankind from natural disasters. Sensed state shall have access to the primary data from the sensing state. Suppose you talk about Nepal, they wanted to use the data. Other than India should help if they wanted to use their own, our own satellite data. Or they wanted to use some other country, so they should also help. Sensing state upon request participating international mutual benefits. Sensing states shall abide by the norms of international and United Nations treaties, and disputes from application of these principles shall be resolved by establishing procedures. So even if you talk about mining activities, so nowadays government also is bringing out a policy or law telling that anybody does this, they should also submit a whole proposal along with the satellite information and then demarcating the boundaries. All that has to be done and then using the satellite data. So, and then some places the evidence comes from the satellite data, and then they will be also taking this as a proof in legal cases also. So actually, when you talk about this, so they have developed these policy guidelines long back, but over the time, something like new satellite data is coming, high resolution satellite data is coming. So then the requirement of this is different from that what you thought earlier some time back. It's something like that you purchase some computer and then use continuously for 10 years, and then you see that your software will become obsolete. All the new programs, softwares comes, you will not be able to load on that. So that means there is a gap between the existing and the new thing comes. So whatever the here new things are coming, so they are not properly brought out in that time. So obvious because that time that much high resolution data was not there. And then they are not addressed this dissemination and usage of very high resolution data, privacy aspects of high resolution data. So something like I buy that something and then high resolution data. Suppose there is somebody property is there, you are going there taking photograph. So it is legally it is not correct. You cannot go into encroach into somebody's property and take their own photograph. But what the satellite data is doing now, so we are having very high resolution data. So 0.5 meter accuracy resolution. So they are able to take that, but how to take care of those things? And then many military activities are also taking place. So these are all the things which are not properly brought out in that. Another thing is legal issues. Something is called licensing. A simple example is suppose you buy some product, some software, and then you use it, and then at the same time you wanted to give it to somebody, and then you say, okay, you also software download and then install it. So as per the legal case, if somebody, the proprietor who is having that, if they come to know that you have issued to somebody else, so legally he is allowed to prosecute you. So that means whatever the license is given is, suppose if it is single user license, you should be able to use for the single system. So like that, all the softwares are also there. Similarly, the product, when you talk about satellite data, when you take that satellite data, you can use it for your own purpose. So it is also mentions that what purpose you purchase. Suppose you purchase for only academic purpose, and then later you started developing, generating some maps, and then you started selling. So that is also wrong. So these are all the licensing issues of products and services. Another is a liability. Suppose I launch a rocket and then it's supposed to go to the space, but it landed in somebody's property. So what are the damages, that liability comes into picture. So you are liable to pay the damages to the property where it has happened. So this comes under a liability. Another thing is, so there are so many issues related to satellite data. So some places, if you talk about microwave lidar data, is very expensive. So when you talk about multispectral panchromatic data, they are cheaper. And at the same time, if you talk about Indian data products, they are available for the Indian users. They are very much cheaper. And then if you talk about some of the satellite data, micro data which is comes, and then it is very expensive. So, and then these are all so many issues are there. One is starting from that, how do you acquire from the satellite and store it, and then process it and distribute it, and then distribute with the pricing for academic purpose, research purpose, commercial. So there are the issues are there, and then sometimes what they do is, if you use for commercial, your licensing or your cost will be different. Suppose if you use it for academic, the pricing is different. You talk about NRSC itself. If you wanted to use for academic, so they give it to 25% of the total cost. So that means 3/4 is cheaper. So, and then if it is used for private, and then come some department, the costing is different. So all the issues are part of the policies. This slide talks about pricing models. Free data for all users. If you talk about Landsat, so they now they made it free. So in between they used to sell it $600 per one scene. It comes around 36,000 rupees. So if you talk about Indian data, so it used to cost 4 or 5,000. So that's why the costs are varies, and then the policy the way you wanted to implement. So nowadays Landsat data is made free, but if you go to Spot, so that is not free. And then if you go to high resolution data, Iconos data, worldview data, so they're also very costly. And then you should be putting at the market prices. Suppose I launch a satellite, I started selling very high pricing, for it will be very difficult for the economically backward countries. One is a full costing, something like I launch a satellite, and satellite is going to be there for 5 years, and it is going to collect the data. And then if I wanted to get back my money what I invested, so then you have to work out what will be the cost for the EC and how many particularly they are going to use. So then based on that your cost also varies. And then two-tier policy. Suppose for university users a different thing, academic, and then commercial it is different. So that becomes a two-tier policy. Information content pricing. Suppose I wanted something in a small area, but because of the way the product is generated, they cannot go with a minimum size. They go in the bigger size. So okay, maybe one topo sheet size, something like that. So I have to buy for the whole data instead of where I wanted. So that is also all information content policy pricing. Access key pricing. See, suppose I access some data, for that whatever I accessed, so the pricing should be there, so that I need not pay for everything, which I don't want. So if you talk about the policies, there are three. I've taken three different countries. One is USA, Europe, and third is India. So Europe is they have a good long-term policy. Basically, when you talk about the satellite data, so now what we are doing is collecting the data. But suppose I collect the data and I am not able to store it after 10 years or 20 years. So our next generation wanted to see how this the climate change has taken place. So for that they wanted to analyze. Suppose if you have not kept the data, how they analyze? That is become an issue. And then see, anything whatever you collect it, which is precious, so you should be able to store it so that anytime it can be used for any type of applications. If you don't store it, then the problem is we will not be able to analyze and conclude into the for the future proper conclusion. You will not be able to draw that. So that's why you should have a good archival policy. So NRSA also they do the data archival policy. And then if you see some of the countries, they have the method of doing it. USA having a strong data collection method. If you talk about this one, Europe, they have no long-term mandate for. They don't have clear mandate for long-term policy. That is project specific archival. If they are working on the project, they are doing Indian medium term policy, 5-year data, no long term policy. So these are the different policies telling about the data. The final policy is internet resources. Nowadays, we have a lot of internet resources available. So one is, as far as the data is concerned, if you talk about a satellite data, if you talk about a field data or census data, meteorological data. So the data is available. Somewhere it is freely available, somewhere is minimum cost, somewhere is actual cost. So this data is an important component in GS. And then when you talk about data, sometimes buying a software is very expensive. So instead of that, probably what you can do is you can use internet resources for computing those things, like a grid computing and cloud computing. So where you use from the net and then started analyzing, and then maybe pay for that whatever you use. And then GIS software, if you talk about remote sensing GIS software, so there are many softwares which are available, COTS softwares, commercial softwares. Another is you have open source softwares. So everyone having their own capability, and then these softwares, you don't have money, then you can go for a open source software. I can mention that OSGEO. So that is the website where they have listed all the softwares, GIS based softwares, and then they also given a provision for downloading those things, and then you can also use them at your place without any cost. So then only you have to acknowledge these things. Another is there are many open source software, Quantum GIS is there, Jump is there, and then Geo Server, Map Server, and then commercial softwares are also there, but many open source softwares. The commercial softwares, they'll take care of the huge data handling. Sometimes open source software they help, but you don't have the support. At the same time, handling of larger these things sometimes difficult. But nowadays, open source software also becoming stronger. So anybody wanted to go in that side, they can also do that and then start working on that. And then there are a lot of learning resources available on the internet. When you talk about web access to geographic information, so there are different sites are there like NNRMS, the country level information they generated through projects, they are also make available for the public. And then Bowen site is there, so they generate for the whole country satellite data, and then they also have a thematic maps, land use, land cover maps at different times. Wasteland mapping is there, forest resources are there. So a lot of information, whatever is generated over the time, so they also kept on the website, Bhuvan, and then made it available. And another is RSGS data reading material, national level spatial information search facility. So this is also made available. And then there is INCOIS is there. So what they do is they collect the lot of information related to the ocean and then try to analyze and then give that warnings, advisory services. And then so that advisory services like fish catching sites or a tsunami warning. So all those things comes under this NCAIS, mainly helping the country in providing the different services. And another is the Meteorological and Oceanographic Satellite Data Archive Center. So it is called a MOSDAC. So MOSDAC is available as part of ISRO at Space Application Center. So telling about all meteorological information, and then what is that? Now the cyclone is active now in the South India. So this cyclonic information, so they also bring out future forecast and put it on the web. Any people wanted to see, they can see, and then use it for their maybe for their basically helping them to evacuate or getting the exact information how it is going to be in a few hours from now, or how much days it will be there, etc. And then there are many education material like USGS lot of materials are there, education, usgs.gov, talking about remote sensing and GPS. And the second is CGIAR, Consortium of Spatial Information. So it is also provides site for downloading SRTM DM data at 90-minute resolution. IRS, I want to announce that we are going to launch e-learning courses soon. So open to all to learn remote sensing and geoinformation science. So one has to register there. So and then start learning that. So we are not yet just open, but we are about to open in soon. So that time you can start using it. These are something about talking about internet resources, and then there are other reading materials. So nowadays a lot of journal publications are happening. Or another is newsletters. So these newsletters also bring out information about the latest development, and the GS development monthly magazine, which is a geospatialmedia.net, where you get a lot of articles and the different types of newsletters. And then my coordinates brings about particularly focusing on GPS and then GNSS systems, provide the information on that latest developments. Indian Society of Geomatics, they also bring the newsletters and remote sensing and these things. And Geospatially today, also monthly magazine and geospatial technologies. GeoPlace, where a lot of newsletter articles, what they bring out. So these are a lot of information which is available on the internet. If you search, you'll get a lot of things. Even a CCRS is there, Canadian Center for Remote Sensing. They have a good reading material on the particularly remote sensing and then emphasis on the microwave. And then there are many websites are there. So if you go to there, so you'll get a lot of information on that. And if you are interested, I can also inform furthermore. If somebody wanted a specific interest, so they can tell me, then I can also help. So with this, I conclude my lecture.